Hi, everyone. Thanks for coming today. Before I introduce our guest, I'd like to remind everybody that this is going to go out on Google Video to the public, and our speaker has not signed an NDA, so please avoid, for both those reasons, avoid asking him secret questions. With that, it's my pleasure to introduce to you Mark Miller. I worked with Mark many years ago, and it was, among other reasons, working with him, it was made that particular job especially wonderful for me. Mark is, I think, the most intellectually honest person I know, myself included, and so it's makes me very happy that he's doing the interesting and important research that he's doing. And he's here today to tell you a bit about that, including some history of Authorization Based Access Control, and its history and about how it's progressed since then and what's happening these days. So thank you very much. And here's Mark.
Okay. So I'm with the Virus Safe Computing Initiative of HP Labs. This is the second talk in the series. Just a poll of the audience. How many people saw Alan's talk last week? Just want to know how much context I should assume. Okay. So for those who did see it, excuse a little bit of repetition. There's not going to be much. In any case, our approach to virus safety, as Alan mentioned last week, is not conventional. The conventional means of dealing with access control, the conventional paradigm of security that dominates today's world is identity-based access control based on first asking the question, who are you? And this approach, after 40 years, has left us vulnerable to viruses, malware, phishing attacks, has basically resulted in today's massive computer security failure. The approach that we're taking, which we've been calling authorization-based access control, where the is based on having the first question be, is this request authorized? And this paradigm also goes back 40 years. It predates the current plague of malware that's infesting us. So the world made a choice between these paradigms and went down one path well before it was faced with today's problems. So today I'm going to be examining the history of the path not taken, explaining a little bit about why it wasn't taken, and trying to explain both how and why we should now be seeking to get on that path. So the path not taken, authorization-based access control, has a curious history. It has a history of formal analyses that were largely negative and practice which was largely positive. It has a repeated history where the practitioners had accomplished some particular end, and then often after the practitioners succeeded at accomplishing that end, the theorists went on to prove that within this paradigm that end was impossible, could not be achieved. What are we to make of this repeated interleaved history of impossibility proofs and existence proofs? So just to recap the history briefly, the first authorization-based access control system was Denison Van Horn's Supervisor. It was an operating system design that was a paper design as of '65. It was approximately implemented on the PDP-1 around 69 to 71, I believe. And it actually has all of the fundamental elements in it well before there was any widespread understanding of what to do with those elements. The interesting thing about going back and reading their paper is this paper was written before the computer field had divided into separate specialties that did not talk to each other. When you read this paper, you find security hardly mentioned at all as a separate concern. They were seeking one set of mechanisms to deal with issues of abstraction, modularity, naming, and access control. They saw the problems as a single fabric, and they approached these problems from the perspective that a single unified set of mechanisms could address abstraction, modularity, and security concerns together. In 1974, Riddell showed an abstraction pattern, an abstraction called the caretaker, that showed how to do patterns of selective revocation, of revocable delegation, so that I could hand out a privilege to several different parties and then revoke it for some of them while still having the privilege outstanding for others. Despite Riddell showing how to do this with an abstraction pattern, in '74, there was repeated statements that revocation was impossible in capability systems, including in many very influential papers as recently as 2003. Also in the early '70s, Lamson had many very influential pieces of work, a capability operating system called CalTSS, and then the papers Protection and Confinement. Protection created the first formal model of access control, and within that formal model, he had a proposed formal statement of both capabilities and access control lists. Capabilities, I'm sorry, I should clarify. Capabilities is the primary means of realizing authorization-based access control. ACLs are the primary means of realizing identity-based access control. You can express either form of access control in either framework, but I'll be speaking within the context of this talk, unless there's questions, I'll be speaking about capabilities as a means of achieving authorization-based access control, and ACLs as a means of achieving identity-based access control. In any case, so Lampson's protection introduced a formal model for comparing access control systems, and within that expressed the capability and the ACL model. Lampson also created the first really important challenge problem for evaluating capability systems and comparing them, which was the confinement problem. Often cited, many claims of achieving it, many claims of impossibilities of achieving it as well. I mean, many claims that various systems couldn't achieve it. And in fact, one of the important facts is that the model of capabilities explained in protection, the formal model that was then used for many formal analyses, was a formal model of capabilities that was weaker than the actual system of capabilities in the Denison-Van Horn supervisor. And in particular, it was weak in such a way that it could not solve the confinement problem. And the weakness of the model compared to what Denison-Van Horn had actually done is, as far as I can tell, previously unnoticed, or unnoticed within that time frame. Kikos in the 80s showed how to do confinement and the star properties, and it did it in the same style that Riddell, in which Riddell solved revocation. It did it by showing a pattern, showing a set of abstractions that compose together to solve the problem. The star properties were another challenge problem that comes from the military. It has to do with the flow of information between security levels, secret, top secret. The military was putting a lot of money into systems that were seeking to solve that problem, so it was driving a lot of the attention. So Kikos showed how to do this using abstraction. In 1984, Bobert wrote a famous paper titled "On the Inability of an Unmodified Capability System to Solve the Star Properties," which was then cited many times including by several award-winning and famous papers over and over again, often misquoted as stating why capabilities couldn't solve the confinement problem. And many of these papers were citing it as an impossibility well after Kiko showed how to do both confinement and the star properties. And the Kiko's patterns were expressible using only the elements present in Denison Van Horn's supervisor. So we have a very weird history here. What's going on? Is it just that people weren't aware of each other? I mean, this was before there was a Google, before there was a Wikipedia, before there was an internet. But the computer science field as a whole was also smaller. There wasn't as much to pay attention to. Is this simply a lack of attention, or is there some deeper source for the confusion? So I've been going back over the works of people in the various schools and the attempt to address each other's objections. And what finally became clear to me is the two schools of thought here were using the same terminology to try to talk to each other while using the same terms to mean different concepts. There is an important distinction that neither side realized in trying to talk to the other. We've been calling the distinction between permission and authority. We've decided to use the term permission for one side of this distinction and the term authority for the other. And essentially what the difference is the difference between causes and effects. Permission is the issue of what actions are directly allowed. So when you do a chmod in Unix and I permit you to read a file, that's permission. As far as the security system itself is concerned, you can say, well, does Dan have permission to read the file? We can look it up and say, aha, Dan's on the access control list or he's the owner and it's whatever, and he has permission to read the file. But let's say that, but now, do I have permission to read the file? Well, I'm not on the access list, I'm not in the group, I don't have permission to read the file, but that doesn't answer the question, can I read the file? If Dan's running a web server in his account, executing with Dan's permission, and Dan gives me the ability to access his web server, and his web server serves pages from including that file, then I can read the file. So I have authority to read the file, where the authority is the effect brought about by the allowed actions, by the composition of causes. So Dan's permission to read the file, Dan's permitted choice to run a web server serving files that Dan can read, and my permission to talk to Dan and thereby talk to a web server that he runs, the composition of these individual permissions and the choices that the allowed choices that Dan has made within the architecture composed to create the effect that I can read the file. So the problem is causality is very difficult to reason about formally. It's very resistant to formal analysis. So the permission is very well illuminated by the lamppost of formal analysis. So the abstract theorists attempting to understand what is and isn't possible in a security architecture were looking for the keys to security in the well-illuminated permissions. The practitioners building capability systems, especially the practitioners who surrounding the Kikos operating system, their intuitions, like the intuitions of any actual programmer dealing with, writing programs to deal with problems are intuitions about cause and effect, intuitions having to do with causality, and they were seeking to control authority. Now, the problem is that if you're doing a permissions analysis, the permissions analysis seems to support various fantasies of centralized control, in particular regarding delegation. The permissions analysis support the fantasy that I can give Dan permission to read a file, I can not give Marcus permission to read the file, and that I've accomplished something by preventing Dan from delegating to Marcus the permission to read the file. With the fantasies of centralized control, with various notions of what a security architecture should be able to do, the capability architectures, and more generally the authorization-based access control architectures, obviously did not support those fantasies. So people who harbored those fantasies could look at capabilities, and the formal analysis was supportive of their intuitions that there's a real weakness there because it obviously can't achieve something we think we should be able to achieve. The permissions-based analysis of access control lists seem to support the ability to achieve these things, and the authority-based analysis still shows that those goals are impossible to achieve, but those results aren't as obvious. So the result is that there was a set of myths that accumulated regarding capabilities. All the quotes in here are quotes from award-winning or famous papers, and also various other variants on the capability paradigm arose that were weak, very much in the same way that Lamson's model of capabilities were weak. So you often hear about capabilities as rows of the access matrix, capabilities as tickets or keys. You often hear capabilities labeled as discretionary. What all these mean are variants of the capability model weaker than the actual capabilities in Dennis and Van Horn's. So what we've done is we've labeled what Dennis and Van Horn implemented as object capabilities. The abstraction and modularity mechanisms that they proposed are in fact very much along the lines of the abstraction and modularity mechanisms in object-oriented programming and the lambda calculus that have provided computer science's great successes of building composable modular software that has given rise to the ever-increasing functionality of the systems that we have. The result of these accumulated myths on access control and the world taking the ABAC path is that we have we're left today with the sad result that Alan showed last week, which is whenever you run any program like Solitaire, you give the program all of your authority. This program can delete any file that you can delete. This is insanity. This leaves us open to today's malware, which is a very different kind of threat than the threats that people were concerned with when they did that early choice of paths. What's going on here? Why do you give Solitaire so much of your authority when you run it? Why don't you give it just the authority that it needs? Well, the choices you have today is you can run it as an application, giving it all of the user's authority, which is dangerous but has all of the functionality that our systems are built to support. Or you can run it as an applet, giving it essentially no authority, in which case it's safe, but it's essentially useless, which is why applets haven't happened and why the current AJAX path that Google is currently on with using JavaScript, which is similarly sandboxed in the browser, why that leaves the AJAX path having to compete with a hand tied behind their back because you can't incrementally authorize the program the sandbox program with the authorities that it needs to function. Java has explored with the Java Web Starts various kinds of static sandboxing that are usability disasters and will only allow you to trade off safety for functionality in an unsatisfying way. Firewalls are neither safe nor are not safe, but still have a tremendous cost in integration across organizations. And of course, anytime anybody shows a diagram like this, what they're going to then advocate is in the upper right-hand corner, and this talk is no exception. So what's the path to usable least authority? POLA is the principle of least authority. How do you provide programs adequate authority so they can provide the functionality you need while still denying them any authority in excess of that would enable abuse? And how do you do that in a usable fashion? Well, the key is what we call dynamic least authority. And the dynamic is the key to dynamic least authority. We saw it at the user interface level last week, which is to bundle the act of designation with the act of authorization. It's dynamically when the request is made, that when you're making a request of something, that's when you're providing it the information about what you want it to operate on. It's not until then that there exists enough information to know what the least authority it is to do what job is being asked of it, because it's not until then that you know what objects it needs to operate on in order to do that job. So by having the act of designating what you want it to operate on be the act of providing it the authority that it needs to operate on that object, we end up with no extra mechanism in the authorization pathway in order to provide applications the least authority that they need that's still adequate to provide all the functionality we associate with applications. What does this mean at the programming language level or at the operating system level? Let's now zoom in from the user interface. So the issue about what's the least authority something needs to do the job, we would like that authority not to be excessively broad. Only if that authority is narrow do we gain safety from practicing POLA. Well, it turns out how narrow that is depends crucially on issues that are not normally thought to be even relevant to security. The issue of how one names things, how one designates. Over here we have two Unix shell command lines that do essentially the same job. They both copy the file foo.txt to the file bar.txt. And both CP and cat, like solitaire, run with all of the user's authority. The actual danger to the user in these two scenarios is the same, which is the user has turned over all of his interests to the program. Both CP and cat are actually run with all the authority needed to destroy the user's life. However, these two examples help illustrate differences in what the least authority would be if you were operating under the right architecture. In the case of CP, CP is provided with the two strings foo.txt and bar.txt. And CP then turns around and does opens to open foo.txt for reading, bar.txt for writing. In order for CP to do the job that's being asked of it to do within this scenario, it has to have access to the user's namespace of files, and it has to already have the ability to read any file the user might name to read, and it needs the ability to write any file the user might name to write. So CP's least authority is still all of the user's authority to the file system. Even if we ran CP under a least authority discipline, it would still have all the authority needed to destroy the user's life. Cat, on the other hand, the user on the second command line is still using names in the user's namespace to say what files it wants cat to operate on, but cat's not given the strings. Cat doesn't know or care what the names of the files are. Those names are essentially evaluated in the user's namespace to opaque references to the designated resources, in the case of Unix, file descriptors, and those opaque designators are then passed to cat, providing cat both the information of what the user wants cat to operate on and the authority cat needs to operate on those files. Cat needs no prior authority in order to do the job the user is asking it to do in this scenario. The authority provided in the request is all the authority that needs to be conveyed to cat in order for it to accomplish its action. Okay. The object capability paradigm can be applied both at the operating system level and at the programming language level, as well as at various other mediums. I'll be speaking in programming language terms, A, because it's more intuitive, and B, because it means that I can use bits of code to illustrate abstract points. It's also the centerpiece of my own research. The object capability, an object capability language is actually very close to simply being an object language. In fact, if you just take the normal notion of an object language and you remove from it all sources of causality outside the object paradigm, you don't remove anything inside the object paradigm, you just remove all other sources of authority, you end up essentially with an object capability language. So the way it works is, when Alice, Bob, and Carol are three objects, and Alice has two variables, Bob and Carol, that refer to those two objects, and Alice invokes Bob, passing Bob a reference to Carol, a copy of her access to Carol. And this is very much like the cat example. What Bob gets is an opaque reference to Carol. Bob gets something that the opaque reference gives Bob both the information of what Alice wants him to operate on, and also gives Bob access to, so that he can make requests of Carol. So he has access to what it is that Alice designated. The key thing is that by removing all other sources of causality, Alice's only means for affecting the world outside of herself is according to the references that she has. She can only affect the world outside of herself by sending messages on those references. And those messages carry references, causing changes in the graph of who has access to what, bringing about acts of authorization. So by simply removing all other sources of causality, a memory-safe object language with encapsulation, the reference graph, familiar from the object-oriented programming literature, becomes identical to the access graph from the access control literature. Yes?
So I would want to say here as well, I don't want Bob to have a reference to Carol except within the scope of the foo operation. I don't want Bob to be able to say that. Is that correct? Because one could imagine an object network propagating capabilities until it just becomes ossified.
So let me postpone that question, and let me give you the label for where that question will reappear in the talk. The label is communicating conspirators. Okay. Okay. So there's actually, the notion of an object capability language actually goes back all the way to Gedanken in 1970. It's had a rich history. Most of the history are languages that you've probably never heard of. The exciting thing is the recent history is leveraging the fact that object languages and object capability languages are so similar because both of them leverage essentially the same abstraction mechanism that Dennison and Van Horn were exploring in their initial work. Jkernel and Joey are both based on Java. Emily is based on OCaml, et cetera. Okay. The diagrams, I'm going to use diagrams in parallel with code, and due to limits of time, I'm going to explain only the diagrams. People who are quick enough at picking up code can follow them in parallel. Make point is a function that makes objects. It's an object that makes other objects. So every time you call make point, it creates new points. The nesting here of spatial containment is lexical nesting. The point is defined within the scope of make point. It can see so any variables that are in scope and make point are visible to point, and the stacking is multiple instantiation. Within the scope of make point, every time make point's called, it makes a new point. So each point has its own x and y variables. So in this case, we're showing is that make point is an object that functions as a constructor or a class or a maker or a factory, depending on what your terminology is. And points are the instances of that constructor. And just a little bit of syntactic sugar. E is a pure object language. I'm showing examples in E. E is a pure object language. The only thing that goes on between objects is invocation message sending. But actually, let's go through it. You'll see what looks like function definition sometimes. That's really just syntactic. The function definition syntax is just syntactic sugar for defining an object with a run method. The function call syntax is really just syntactic sugar for invoking the run method of an object. And when you see operators like plus, it's just syntactic sugar for sending an add method. So really all that's going on are objects and message sends. Okay. Now let's start to address your question. Okay. So when Alice sends Bob a reference to Carol, in an object system as well as an object capability system, she's giving Bob irrevocable, permanent, unconditional access to Carol. And total access to Carol. Whatever can be done by sending messages to Carol, Bob can send any of those messages. So we'll call that unattenuated delegation. And a lot of the security properties that people have argued about over the years come down to various different ways of handling delegation. For example, Riddell's pattern of revocable delegation, which we're going to show here. So if Alice wants to give Bob access to Carol, but only for a while, she wants Bob no longer to have access to Carol after some future point in time, what she does is she doesn't give Bob direct access to Carol. She interposes an intermediary. And the intermediary Riddell called the caretaker. So she instantiates this intermediary. And the intermediary, there's an object called the caretaker. What the caretaker does is every time she gives Bob access to the caretaker side of the intermediary, and she holds on to the revoker side. The caretaker, whenever it gets a message, such as a message from Bob, it's going to forward the message on to whatever the current value of this target variable is. When Alice invokes the revoker, that's going to set this target variable to null, and that will prevent further messages from Bob from getting to Carol. So, from a permissions-based analysis, everyone who said capabilities cannot revoke access, capabilities, in fact, cannot revoke permission. So the permission Bob has been given is permission to invoke the caretaker. So if Bob says to the caretaker, if Bob's name for the caretaker, let's say, is Carol2. Carol2, do this. The caretaker will forward that on to Carol. If Alice says to the revoker, revoke, that sets the target variable to null. And now this transitive line through the caretaker pattern is showing authority, not permission. It's showing, based on the behavior of the intermediary, as composed together with the permissions through the structure, it's showing that while the structure is live, while the caretaker forwards messages, Bob effectively has authority to invoke operations on Carol, i.e., Bob can cause actions whose effects are that the message do this is delivered to Carol. However, after Alice does the revoke, the caretaker's behavior changes such that it no longer forwards messages. So when Bob says, Carol2, do that, those messages no longer get forwarded. So the result is that no permissions were revoked here. So everybody said capabilities cannot revoke. Their statement is correct on permissions. Bob still has access to the caretaker. The practice of actual object capability practitioners, which is not captured by most of the formal theories, is the practice of building access abstractions. So that's the paradigm that we're regaining here. By what the base level abstractions are references, permissions, giving direct access. The abstractions of interposing intermediaries are like building smart references that give controlled access. In this case, controlled by Alice according to when she decides to revoke. Other kinds of intermediary create abstractions that control what rights were delegated to Bob in different ways. Okay. One of the greatest source of criticism of the object capability model has to do with the propagation of delegation, which is what we're showing here in this diagram is that Alice has some particular access to some particular object, perhaps Carol, that represents some power. Whoever can invoke this object has the power to do some particular things. And Alice would like to give this power to Bob. However, Alice, the thought bubbles here are not what Alice thinks, but what Alice wants. Alice wants Mallet not to have the power. Mallet wants Mallet to have the power. The two question marks here are a way of developing a taxonomy of issues in controlling delegation. The two question marks represent the two questions. Does Bob want Mallet to have the power? In other words, is Bob coded with the intention of serving Mallet's interests? Or is Bob coded with the intention of serving Alice's interests? And the other question mark is, does Bob properly have access to Mallet? Are Bob and Mallet properly in communication? Should they be able to speak to each other? Depending on the answers to these two questions, we can divide the remaining issues in delegation into 4 subproblems, which I'll now go through. If Bob is on Alice's side, i.e. Bob's intention is to serve Alice's interests, then if Alice doesn't want Mallet to have the power, presumably Bob will act in a supportive way. And if Bob and Mallet are not in communication, then the only remaining question is perimeter security. Can Bob break in and take it? And any access control architecture has to start by assuming, any security architecture of any kind has to start by solving perimeter security, and all access control work has to start from the assumption that perimeter security has been solved, so we can now go on to the remaining problems. Okay. Lampson's confinement problem says, well, what if Bob has been coded to serve Mallet's interests? Bob and Mallet are still not supposed to be able to talk to each other. But both Bob and Mallet would like Bob to wield this power in service of Mallet's interests. Can Bob effectively delegate the power to Mallet, despite the fact they're not supposed to be in communication? Okay. Our third subproblem is the confused deputy, which Alan referred to last week, which is Bob has been is supposed to serve his client's interests, i.e. supposed to serve in this scenario Alice's interests, but let's say is separately coded from Alice. Alice is depending on Bob to serve her interests, so Alice is entrusting the power to Bob. Bob and Mallet are properly in contact. Bob is supposed to be serving requests from Mallet, but without making the power in question available to Mallet, i.e. he's supposed to make use of the power in some limited way so that Mallet doesn't have all of the authority represented by that power. And now the security question comes down to, can Mallet confuse Bob into accidentally using the power on Mallet's behalf rather than according to Alice's interests? And the final subproblem is communicating conspirators, which is Bob has been coded to serve Mallet's interests. Bob and Mallet are properly in contact. Can Bob and Mallet can Bob be both given the power and prevented from delegating the authority to use the power to Mallet? So we take the two questions, each of which have two answers. We take the cross product, and we've got the four scenarios. The confused deputy is a talk by itself, which I'm not going to talk about today. You can also Google search for it and get plenty of hits on the web. It's well explained on the web. But these are links to further material that I'm prepared to answer questions about. And at this point, I'm going to turn it over to questions. You can ask me about anything, not just to follow these links. But these are there so that there are opportunity for more material to answer questions. And let me skip over that and just do some wrap-up slides here. This is the money example, which actually I'm going to say a little bit about. So Alan showed the money example last week. I'm also prepared to explain it. But the point I want to make with it is that the early computer security work was funded was driven by the expressed needs of the military, was driven by practice within corporations, both of which had centralized models of control, and both of which saw delegation as the problem and the propagation of delegation as the problem and wanted to control delegation. And because that's the history of challenge problems, was in terms of controlling delegation, that's the history that has to be answered to explain what happened. However, the modern, that set of challenges is badly suited to the modern world. The modern world is one of decentralized cooperation between organizations and among individuals. And for that world, the primary issue is not to limit delegation. We should embrace delegation. Delegation is our friend. The entire division of labor of the marketplace, giving rise to the fact that I can ask you to do something and you can subcontract to somebody else, et cetera, and that I don't even have to know who it is you're subcontracting to. This decentralized activity we call civilization is founded on chains of delegation. we should be seeking to support delegation, not to inhibit it, but we should be to support delegation, we should be seeking to do so in ways that work according to least authority. It's the excess authority that we grant when we delegate anyway within architectures not built to support least authority delegation. It's that excess authority is what has created the world of massive failure of computer security, of viruses and other malware that is the disaster of security that we're currently living in, coexisting with the vast successes of functionality built on the abstraction mechanisms that are close kin of the security mechanisms that I've shown today. Okay, questions? Okay. Yes? Can you talk about the communicating conspirators problem? Okay. So, communicating conspirators, that link takes us back into our caretaker example. What this is about is the answer to the communicating conspirators problem is that it cannot be solved. The fantasy that it can be is one of the terribly damaging fantasies that led people away from capabilities, because in a capability architecture, it obviously cannot be solved. So here is the demonstration of why it can't be solved in any architecture, which is, let's say that we're in an access control list architecture. And now we've given Alice permission to access Carol. Carol is a file, we've done a chmod or whatever. We've given Alice permission to access Carol, and we have not given Bob permission to access Carol. Well, if Alice practices least authority anyway within this access control list architecture, then if she doesn't need, then let's say Alice doesn't think to try to give Bob permission because that would give Bob too much authority. Alice wants to give Bob some limited permission, so she imposes an intermediary, like a web server in our previous example. Well, this intermediary executes with Alice's authority. The permission Alice is giving to Bob is a permission to access her intermediary. There's no attempt in this scenario to give Bob permission to access Carol. So the fact that we went out of our way to construct a security architecture that could deny Bob permission to access Carol did nobody any good. But because Alice interposed an intermediary for reasons, not because she was seeking to work around the prohibition, but for other reasons, has inadvertently thwarted the intent of the prohibition. So let's state what's being sought here, and we can see why it's impossible. What's being sought in the communicating conspirators problem, phrased in cause and effect terms, is that we want, let's go back to the scenario. Which is, Bob and Mallet are stateful, they're in communication, so Bob can be affected by Bob's state can be affected by communication with Mallet. Bob can make use of the power. Bob can decide how to use the power in ways that depend on his own state. That's what we're saying we're allowing. What we're disallowing is for Mallet to use the power, i.e. for Mallet to be able to exert causes that bring about effects of the power used on Mallet's behalf. The statement of what we're prohibiting and the statement of the initial conditions of the problem are in fact formally identical. We've just used different terms to phrase it in ways that seem to be in conflict. Okay, well, in the absence of questions, I'll just keep speaking. So confinement, okay.
I had a question about revocable delegation.
Yes.
So the example of the caretaker pattern you were showing. So I guess there's a danger to not put in Carol, to say Carol has some method which is return a reference to myself.
Wonderful. Yes.
Call that method and get around the caretaker.
Yes, that's exactly right. I'm sorry? Oh, yes, repeat the question. So the observation is that this caretaker pattern is fragile. This is a correct observation. The caretaker pattern is only usable when Alice knows enough about Carol's behavior to know that Carol will not reveal to her clients, reveal in response to messages, direct authority to her or authority to other things that Alice would have liked to revoke. So in fact, that's correct. You use the caretaker itself only when Alice is confident of that Carol behaves in such a limited way. There's a similar pattern called the membrane, which in the same language, in E, takes only 24 lines of code. So it's too big to fit on a slide, but what it does is, as each reference comes in as an argument or comes back as a result, it gets rewrapped essentially in another caretaker, and then the revoke action revokes all of the transitively wrapped references that have gone back and forth over that membrane at the same time. So what the membrane, if you surround something, we call it a membrane because as the thing that you've put it around expands, the membrane sort of expands to continue to be a barrier between it and its clients. So it doesn't matter how much it expands. As further references go back and forth across the barrier, it just continues to expand to continue to stay interposed. Okay. So on language design, there's a curious thing that happened, which is people following the object/lambda calculus abstraction mechanism pathway have built, for the sake of abstraction, modularity, and functionality, languages supporting message passing, encapsulation, memory safety, garbage collection, et cetera. And those elements take you up to object-oriented programming. There's now been enough work on different kinds of secure languages, by the way, that we can now show what the roadmap is in hindsight. We have the benefit of hindsight for understanding the roadmap. So Scheme had some additional elements, lexically nested objects, which turns out to be very synergistic with a lot of object capability patterns. It makes a lot of object capability patterns, like the caretaker, very easy to express. And it has safe loading, so that you can load code from untrusted sources and know that the loaded code is restricted to making use only of the elements in the environment in which the loaded code was evaluated. So that's a safe eval, essentially. Java and .NET had the misfortune of having gotten essentially those elements, but some further elements by the time they asked themselves, what about security? So Scheme had the original set of elements. By the time it asked itself, well, how do we address security within the context of our language? Java additionally had mutable static variables. It had static native devices like file.open. By devices, I mean native methods that enabled I/O to the outside world. And it had this large accumulation of libraries, many of which were not written to good modularity principles. So by the time they asked themselves what to do about security, those additional elements made the answer very hard. And they kept adding mechanisms to Java and to .NET, .NET essentially following Java on this path. They kept adding mechanisms to seek security and then declaring the result to be a success. And Scheme, on the other hand, having those initial set of elements that in which causality is still only along references and there's control of scoping, by the time they asked themselves about security, Jonathan Rees's PhD thesis shows a variant of Scheme called W7, which is a very small delta from Scheme. Essentially, he was able to just step across the barrier into object capability security because he was starting from a language that didn't have those additional elements. What you need beyond that is, for a modern, safe object capability system, is libraries written according to the principle of least authority, as well as safe reflection. The lesson from this roadmap drawn in hindsight is that the detour on this road, the thing that led Java and .NET into needing to continue to add mechanism, seemingly with no end in sight, is the sources of causality outside the object paradigm. To get back on the road, it's not so much that we have to add things, is that we have to remove the sources of causal access that took us off the road. This is not a loss of functionality. It's just a loss of ability to express the functionality in certain non-modular ways. Yeah?
You guys thought, since you mentioned Java, you thought about using some sort of aspect-oriented programming framework inside of Java to implement some or all of what you're doing?
So there's, I don't understand aspect-oriented programming well enough to make informed statements about the correspondence between the two. I'll state my concern, but first of all, the answer to your question about whether people have looked at it is, to the best of my knowledge, none of the people concerned with achieving security in this paradigm overlap with the people who've been deep into the aspect-oriented programming perspective. I'm not aware of anything in the intersection of those two. Marcus?
And just so you know who it is you want to talk to, okay, David Wagner and Adrian, what's his last name?
Mettler.
Adrian Mettler at Berkeley are the people who are creating Joey, which is the object capability version of Java. Okay. So the thing to do is to email David and Adrian and say, we thought about how would aspect-oriented programming engage with this, and you could have some
Okay. Is there anything anybody would like me to expand on? And if not, we will wrap up. And I'm available for further discussions. Okay, well, thank you.